Okay guys, let's get started. This is our review for Unit 6, which is the last unit of the first semester here. So, first of all, evaluating expressions with exponents. Look at the first one here. So negative 4 squared, what's being squared is 4. The negative is not being squared, so this is negative 16. As opposed to the next box, this is negative 4, all of that being squared. So that is positive 16. Over here, you see the negative of 4 times 4. So that's just negative 16. That's another way of writing the first problem you saw here. So these problems are doing the same thing that you see circled there. Let's look at the last one on that top row. With negative exponents, the way I handle negative exponents is I can make them positive by moving them wherever I find them, moving them to the other spot. So for example, that's in the numerator, that's the top of a fraction. That exponent becomes positive if I move that term to the bottom of a fraction. So this is going to be negative 1 over 4 squared. So if I can move the 4 to the denominator, that negative 2 becomes a positive 2. So this is simply negative 1 over 16. If I look at the bottom 4 to the 1/2, raising something to the 1/2 power just means I'm going to take the square root. So that is the square root of 4, which is 2. If I look at the next one, it's the square root of 4, but with a negative in front of that. So this is the negative of the square root of 4, which is negative 2. If I look at the next one, this is the square root of negative 4. So there are no real solutions for this. So this is not real. If I look at 1 over 4 to the negative 2, so 1 over 4 to the negative 2 is the same as 4 squared over 1, which is 16, okay? So this is just walking through properties of exponents, how to apply them, positive exponents, negative exponents. Problem number 2 here, continuing on, properties of exponents, but I'm working with expressions and making sure that I can obey the laws of exponents. So in this next one here that you see, 36 m to the 4th over 49 to the 1/2, that is the square root of everything that you see here. So that's the same as writing the square root of 36 m to the 4th over 49, okay? So the square root of all of that. The other thing I could do is just distribute the 1/2. So this is the same as writing that's 36 to the 1/2, m to the 4 to the 1/2 over 49 to the 1/2. And then to simplify this, 36 to the 1/2. That's the square root of 36. And then m to the 4 to the 1/2. So 4 times 1/2, that's just 4 over 2, which is 2. And square root of 49 is 7. So 6m squared over 7. So just applying properties of exponents to get the solution there. In the next one, what's being squared is a to the 5th c to the negative 1, not the negative 3. So this is negative 3. And then I can just multiply exponents. So 5 times 2, that's a to the 10th. And then negative 1 times 2, that's c to the negative 2. To write this with no negative exponents, that's negative 3a to the 10th over c squared. If I look at the next one, again, several ways of doing this. I can go ahead and move the m to the 5th to the bottom. So 2 over m cubed, m to the 5th. And then anytime I have two numbers multiplied with exponents, the same number, I can add those exponents. So this is 2 over m to the 8th power. If I look at the next one here, it's a little bit confusing, so it's just testing that you can keep everything straight. I could move things around and get all positive exponents. That's one strategy. Some people like to do that. So let's just try that. So x squared, that's the first term. On the top, I've got a y to the negative 2. Well, that's a y squared if I move it to the bottom. And I have a z cubed. Now on the bottom, I've got x to the negative 2. That's the same as x squared if I move it to the top. That y to the negative 1 on the bottom is the same as a y to the first on top. And the z squared is where it is. So that's one way of looking at it, get everything with positive. And then with exponents, I can say, okay, I've got x to the 4th, y z cubed on top of that fraction. And it looks like I've got y squared, z squared on the bottom of that fraction. So my x terms, that looks to be as good as I can do there. This is going to be x to the 4th, and then y to the 1 minus 2, z to the 3 minus 2. Okay, remember with fractions, if I've got a to the m over a to the n, that's the same as a to the m minus n. I subtract those fractions. So this is x to the 4th, y to the negative 1, z, which is just x to the 4th z over y. Okay, and that is in the simplest form. Problem number 3 is solving equations. The big thing I'm looking for is even exponents or even numerators. That tells me I've got a plus or minus in my answer. So in this case, if I look at the first one, I've got something cubed. So I need to raise both sides of this equation to the 1/3 power. So x plus 2 cubed equals 64. I'm going to raise both sides of this equation to the 1/3 power. So the reason I do that is on the left side of the equation, I will get x plus 2 equal, and then I'll get 64 to the 1/3. So that means that x plus 2, 64 to the 1/3, that just means the cube root of 64. A number that you can multiply by itself 3 times and get a 64, that's just going to be 4. So x is going to be equal to negative 2 plus 4, or x is equal to 2. X to the 4th equal 81. That exponent 4, that's even. That's an even exponent, so I'm going to have to take the 4th root, and I'm going to get a plus or minus in my answer. So if I have x to the 4th equal 81, I'm going to raise everything to the 1/4 power, and then I'm going to get x equal plus or minus 81 to the 1/4. That means the 4th root of 81. What number can be multiplied by itself 4 times and get an 81? That number is 3. So x equals plus or minus 3. X to the 2/3 equal 25. So the numerator, when I've got that 2/3, that 2 is an even number. That means I'm going to have a plus or minus in my answer. So x to the 2/3 equal 25. Both sides of this equation will be raised to the 3/2 power. So I would get x equal plus or minus 25 to the 3/2. 25 to the 3/2, that means the square root of 25 cubed. So this is x equal plus or minus square root of 25 cubed. The square root of 25 is 5. So this is plus or minus 5 cubed. 5 cubed is 5 times 5 times 5. So this is x equal plus or minus 125. X squared equal negative 72. So x squared equal negative 72. This is going to require me to take the square root of both sides. That is square root of a negative number. So there is no solution to this one. So the next type of equation are the power equations, where I'm solving for x, but x happens to be an exponent in this case. So the strategy here is I have to be able to manipulate this so that on both sides of the equations I have the same number raised to a power. So if I look at the first one, I've got 2 to the 5x equal. So my key is when I look at that number 16, can 16 be written as 2 to a power? Well, yes, that's 2 to the 4th. So I've got 2 to the 4th to the x plus 7 power. So this means that 2 to the 5x equal 2 to the 4 times x plus 7. So now if you look at it, I do have the same number on both sides of the equation raised to a power. So I just need to solve 5x equal 4x plus 7. So 5x equal 4 times x plus 7. That means that 5x is equal to 4x plus 28. If I subtract 4x from both sides, I get x equals 28, which is the solution to this guy. Okay, the next one going across to the right, 1/2 to the 5x equal 32. So over time, these numbers start to run together and you'll start to see patterns of which numbers I'm picking. If I look at 1/2, you got to be able to recognize 1/2 is 2 to the negative 1. It is a power of 2. And then 32, well, 32 is 2 to the 5th is 32. So I can write this equation in terms of powers of 2. So this is 2 to the negative 1 to the 5x is equal to 2 to the 5th, or 2 to the negative 5x equal 2 to the 5th. Now I have the same number on both sides of my equation raised to an exponent. That means that these exponents have to be equal. So I know that negative 5x equal 5, or x is equal to 5 over negative 5, or negative 1. So x is equal to negative 1. 5x to the x plus 1 equals 125. So this one, on the left, you've got 5 to the x plus 1. 125 is 5 cubed. So this one, I know that x plus 1 equals 3. So x is equal to 2. And the last one here, this is the one that get tricky when you have the fractions. So I've got 3/4. There's not much I can do to simplify that, or yes, no, I'll leave it like that. So 3/4 to the 2x. I can write 9 as 3 squared. I can write 16 as 4 squared. So if I do that, then I've got 3/4 to the 2x equal 3/4 squared. Now I have the same thing on both sides of equation raised to a power. That means those exponents must be equal. So 2x has to equal 2, therefore x has to equal 1. So again, with these power equations, the big key is getting the same number on both sides of equation raised to a variable or an expression. Once you do that, then you can set the variables equal to each other. Let's look at graphing 3 to the x plus 1. So the key here is to pick 3 points, and then you can tell what the graph is doing. What I will look at is I want to pick where the exponent is 0, and then one number on either side of that. So I've got 3 to the x. So if when x is 0, that gives me the exponent being 0. And then I'm just going to pick a number on either side of that, okay? And then figure out what y is equal to. So let's start with 0. So 3 to the 0 plus 1. 3 to the 0 is 1. So this is 1 plus 1. This is 2. Let's go to 1. 3 to the 1 plus 1. That's 3 plus 1, which is 4. And the next one, 3 to the negative 1 plus 1. That's equal to 1/3 plus 1. So that is simply, that is 1 and 1/3. So I need to graph these points. 0, 2 is right here. 1, 4, which I see here. And negative 1, 1 1/3. So it's somewhere right here. Okay. Now I'm going to go ahead and graph this, but before I do, one step. To find the horizontal asymptote with all of these graphs, you'll just look and see what is the number out here by itself. That number is 1. So that tells me that I have a horizontal asymptote at y equal 1. So that's my horizontal asymptote. I can go back now and graph this. So here's where I see the exponential growth and then the exponential decline. So it approaches that asymptote. The domain of this function, well, let's back up before we write the domain. The horizontal asymptote is y equal 1. The domain of this function, if you look at the left and you start traveling from left to right, you're getting all values of x. The domain is negative infinity to infinity. If I go look at the range of this, that means I start down here at the y-axis. There are no values until I get to 1. So it starts at the asymptote and it goes to infinity. And because it's an asymptote, I've got a parentheses, okay? Because it never hits that number, it's always approaching it. So that's the graph of 3 to the x plus 1. Let's look at another graph, 3 to the x minus 1 plus 1. So what I want to do, I want to pick where does x minus 1 equal 0? That's at x equal 1. So that's the middle point here. So I'm going to pick that point where the exponent is 0. My exponent is 0 when x is 1. And then I'm going to pick a number on either side of that. So 2 and 0. Those are the two numbers on either side of 1. And now I'm just going to plug these values in. So let's look at, in the first case, let's start, I just like to start with the middle one. So 3 to the 1 minus 1 plus 1. That is 3 to the 0 plus 1. That is 1 plus 1, which is 2. So 1, 2. Then let's look at what I get when I get a 0. This is 3 to the 0 minus 1 plus 1. That's 3 to the minus 1 plus 1. That's 1/3 plus 1. So that answer is just 1 and 1/3. And then if I look at the last value, 3 to the 2 minus 1 plus 1. That's 3 to the 1 plus 1. That is 4. So in graphing these points, before I graph it, I'll look my horizontal asymptote, whatever that number is, out by itself. So y equal 1 is a horizontal asymptote. So I can draw at y equal 1 this function. So that's y equal 1. And then if I plot my points, 0, 1 and 1/3. So 0, 1 and 1/3 is sort of right here. 1, 2 is right here. And 2, 4 is right here. So same shape, it's just this graph has been shifted a little bit from what we see on the other one. So I can tell if I go back to this other graph, this was what, 3 to the x plus 1. When I put an x minus 1, that's shifting everything to the right by 1, which is what you see reflected. You should have the same domain here, negative infinity to infinity. And the range is going to be 1 to infinity. Those are all my y values on this graph. Now let's look at an example of a transformation of a graph. Consider the transformation from f of x equal 4 to the x, that's this first graph right here, to g of x equal negative 4 to the negative x minus 1 minus 1. Now, the best way to do this is to write g of x equal negative 4, and what I want to do is I want to factor a negative 1. I want to write that exponent. That's the negative of x plus 1. Okay. So instead of negative 4 to the negative x minus 1, I want to write it where my exponent is in parentheses, and I factored out a negative 1. Now I'm able to read this graph like you know how to read functions and transformations and tell what happened. Okay, so has it been reflected about the x-axis? If that's the case, I got a positive in front and a negative in front. Yes, the negative in front of this entire equation tells me it's reflected about the x-axis. Has it been reflected about the y-axis? You look at your exponent, 4 to the positive x. And then over here on g, I've got 4 to the minus x minus 1. So I've got a negative. So it has been reflected about the y-axis. If I look at a vertical shift, the negative 1 off to itself over here tells me I've shifted 1 unit down. And then if I look at the exponent inside parentheses right here, when I see that x plus 1, that means I've shifted 1 unit to the left. So in this case, I've shifted 1 unit to the left. Okay. So that's a transformation. The key there is when you see that 4 to the negative x minus 1, you want to write that like you see here, negative of parentheses x plus 1. Okay, that way you make sure you get that transformation horizontally correct. Number 8, write the equation from taking f of x equal 4 to the x, reflecting it about the x-axis, shifting to the left by 4 and down 4. So let's create a new function. So let's do one thing at a time. To reflect it about the x-axis, that's a negative sign. Okay, then I'm going to have 4, and then it shifts to the left by 4. So left 4 is x plus 4. That's what shifts it to the left plus 4. And then it goes down 4 units. That is this. Okay, so negative in front is the reflection about the x-axis. The exponent x plus 4, that shifts it to the left 4. The negative 4 at the end shifts the whole graph down by 4. Now I did not ask it, but if I did ask you for this, the horizontal asymptote for this, all you have to do is look and see whatever that number is. So it's y equals negative 4. Okay, that should be it for the review. Alrighty, thanks.